starting point for the two half reactions. Chromium I3 goes to chromium O42 minus and 3iO4 minus. And for the second half reaction, H2O2. And we're now ready to complete the balanced equation with these final two steps. It looks like a lot of words, but this is extremely mechanical, and I actually find it kind of relaxing. There are two parts. First, we're going to correct what's the correct order for the balancing of the half reactions, and you must follow the order as prescribed. 3 steps. First, balance the half reactions for oxygen using the H2O molecule. So you can see that in the first half reaction, there are 16 oxygens on the right side, 4 from the CrO42 minus and 12 from the 3iO4 minuses. So I need to add 16 H2Os. And I do that for the other reaction. There's 2 O's here. It's 2 H2Os. I've now balanced for oxygen. Now we're going to balance for H using the H plus ion. Well, there are no H plus ions in the... there are hydrogens now in the first one. There are 16 H2Os. So I'm going to need 32 H pluses to balance H's. And in the second half reaction, I have 4 hydrogens on the right, 2 hydrogens on the left. I'll need 2 H pluses over here. Good. It's kind of balance both half reactions for charge. The left side here, this is now neutral. But the right side, if we look at the right side, it is 32 pluses and 5 minuses. So we need to add 27 electrons. In the second reaction, we have, it's neutral over here. On this side over here, we have 2 H pluses. To balance, we need to add 2 electrons. And we have now balanced for charge. Good. We've completed the first part, the A part. We balanced the two half reactions for charge, H and O, and in the correct order. We must now combine the two half reactions. And the key is the number of electrons. We're not going to have electrons over. Electrons are not something that's there in water normally. And so free electrons, so we need to get balanced. So we need to have the same number of electrons on the left and the right. And the way we're going to do that then is we'll take the two parts and I'll multiply this by 27. And I'll multiply this whole reaction by 2. And that way I will have the same number of electrons on the two sides. I can now add the two half reactions together. So I'll just read what it says. Sum the two half reactions in the last step to make a whole single balanced reaction. I'll do that in magenta. The electrons cancel. I'm not going to worry about that. I've got, remember there's a times 2 in the top, 32 H2Os plus 2 chromium I3s. Then I can do more what's on the right. I have 2 times 27, 54 H pluses, and 27 H2O2s, going to 2 CrO42 minuses, plus, see there's a 3 here, times 2, 6 IO4 minus, plus 64 H pluses. And we don't have to worry about electrons because we have the same number of electrons on the two sides. And finally we have the number of waters plus 54 H2Os. And you can see that we have H pluses on both sides. We've got 54 H pluses over here and 64 H pluses over here. And we can therefore get, there are 54 on both sides. These are called spectators. We take those out, we're going to end up with 32 H2Os plus 2 CRI3s plus 27 H2O2s, taking off 54 H pluses on both sides, going to 2 CrO4 2 minuses plus 6 IO4 minus plus 10 H plus 54 waters. But I told you that this reaction takes place in base. In base, you have water and OH minus. You do not have H plus. And that brings us up down to the final step. If the reaction is carried out in base, so we would be done if this reaction was carried out in acid. That would be the balanced reaction, but it's carried out in base. Add hydroxides to both sides. And when you add hydroxides to H pluses, they make waters. So what we're going to do is we're going to get rid of all the H pluses because there are no H pluses here, and therefore we're going to add to both sides 10 OH minuses. To be balanced, we have to add 10 OH minuses to this side, and we end up with, when we do that, we end up with 32 H2Os plus 2 CRI3s plus 27 H2O2s plus 10 OH minuses, 10 OH minuses, going to 2 CrO4 2 minus plus 6 IO4 minus. The 10 H pluses plus the 10 OH minuses combined to make waters. That's 64 H2Os. We're not yet done. Almost done. What we have to deal with is that there are waters on both sides. We've got 32 H2Os on this side, and we've got 64, which means that there are 32 H2Os that are spectators and should be canceled. We're ready to write the final reaction. 2 CRI3 plus 27 H2O2 plus 10 OH minuses going to 2 CrO4 2 minuses plus 6 IO4 minus plus removing the 32 H2Os, and this is the balanced aqueous chemical reaction. And just as a note, we have now, just what it says, the whole thing has been loaded with the right number of OH minuses. There are no remaining H pluses. This indeed is the correct reaction. And you'll be given, there's some exercises in the type notes where you can go through this procedure and master it yourself.